measurements all involve uh, change and dimensions, and obviously objects of change and dimensions. You can't escape objects, change, and dimensions. And you have to also understand what they are, or identify what all of your dimensions, your changes, and your objects are. Well, at least for the most part. A dimension can be just about anything, even energy, or even an unknown force. Changes can be potentially a lot of different dimensions, and possibly even just absolutely random. Even though randomness, probably technically, by the law of truth, randomness doesn't exist. There's no such thing as random. Random does not exist. Everything happens for a reason. You can never have true random, because technically in quantum physics everything is connected. Unless, obviously, there's no interacting energy, but most likely there is an interacting energy, even in a distant universe, because of forces, even tiny forces. We're not really sure how things amplify either, so that's another dimension, is like almost magical changes, or magical dimensions, or magical objects that have amplifications and different kinds of dimensions and different functions. So, like, I am one of the least magical people you ever knew, but basically, you're gonna put all your objects, your dimensions, and your changes into an integral formula, or maybe a differential formula, and you're going to calculate with a large formula of all of your changes, your objects, and your changes, objects, and dimensions. You calculate how things interact, or react, or function, or move, or how they have magnitude, or how they act as a vector, or how they have motion, or how they disappear, or how they reappear, or how, just started creating functions from nothingness, from absolute nothingness, and simulate with your tensor / integral differential, simulate your quantum physics. And you will start to understand that even if your math isn't true, you could start to conceptualize things that either are or aren't phenomenon that we do or don't understand or even know about. You can learn about how light crashes into itself. You could learn about how magnetic fields collapse. You could learn about how electrons decay. You could learn about how nucleuses of atoms vibrate. You could learn about how particles undergo certain motions within atoms. You could learn about the size of X-rays. You could learn about the motion of light through a medium. You could learn about particle fields, how they interact or how they could do funny things and strange who knows what, how they can change shape, size, function, motion, whatever a particle can do. How that not only are they particles, but maybe they either also could have infinite dimensions. You need to know that, like, dimensionality, if it doesn't have a lot of angles in a volume can have infinite dimensions, and you need to know that primarily, and that you need to also know that things are, by a mathematical standpoint, things are infinitely divisible. And that is a theory called string theory. That's only a part of string theory. But that's a different kind of string theory. That's interdimensional string theory, where we don't know what's really happening in particles. Because it's not possible to measure the smallest particle inside. Could be universes everywhere. We could be walking through a sea of universes. We are made of seas of universes. We don't know that. We're universal gods of the universe that don't mean shit. We're in a sea of universes. It's the most fucked up thing ever. Existence is stranger than fiction. Fiction actually might be the reality we always dreamed of. But we live in a reality, and it bites ass, and it might be it might be stranger than any fiction. So, I don't know, but interdimensional string theory says something to me. Can't imagine what's really happening inside the sun. If there really was some type of interdimensional string theory of universes trapped inside of particles. But some strange shit if it was. They probably don't communicate very well. They might. We don't know yet. If we do actually find a particle that communicates with the smallest known particle, like I think those are what we consider right now bosons or quanta. But like, that's probably not as small as it gets. If particles really are divisible infinitely, or even partially infinitely, or partially, or how many ever times they will divide, what is that really? No one really knows. We don't know how to divide all particles infinitely. May not be achievable. Actually, it may take a very massive machine to do something of this nature. I mean, so massive we can't hypothesize the amount of energy it would take. We haven't even gotten that far yet. Like, Could you imagine splitting a photon in half? What would it be like to cut a photon in half? Or a tenth? So, like, dimensions. These are all things you can summarize as dimensions. It is the change of all things in the entire existence of the universe, of all universes. It's called change and dimension. It's pretty much what we battle on an everyday basis. That's why we live and die. That's why we have beliefs. That's why everything is good and evil. So it's pretty much energy right now. Energy and medicine. That, and then we also want to sustain the solar system and travel through regions far beyond. So, interdimensional string theory. Try falling back into the couch so far that you fell inside of a photon and found yourself talking to yourself when you were someone else. It's just strange. There's a lot of hypotheses, I guess you might say, if you really want to get into what's possible or what's real. But we have solved the Matrix. I have solved the Matrix. I'm pretty sure we're not in one of the Matrixes. Like the movie, I don't think we're trapped in a Matrix, really. We're more like trapped in a universe of strange, unknown physics that haven't happened yet, or whatever. And there's a lot that we know. You know, we got 5 fingers, and there's like God, there's magic, there's spirit, there's machine, and there's nature. And that's kind of the assemblage that we kind of throw around a lot. And what's it really do for us? I don't know. As you can see, we're not perfect sometimes, quite often. A lot of us are definitely not perfect, but we have a lot of us have gifts, even though we're not perfect. We conceptualize a gift of some sort, and some of us are able to think. May not be the most beautiful thing in the world, but we can think, and you know, it's a handed down and recently learned. Science is kind of new. Really, it is. It's pretty new. It's really only about 520 years old. Before that, science was still here, obviously, but it wasn't very robust. It wasn't known. There were Greeks and Egyptians and people, but we don't know everything about history because a lot of this stuff is somewhat prehistoric, and we don't know everything. They did have sciences, like the Egyptians used to put organs inside of canisters, and they studied matter and metal, and there were different ages of like science, really, but they weren't nothing like what we know right now. This is 2022, since Jesus Christ, but we know not. We know pretty much conceptualize. think we conceptualize everything. Seems as though we might. I mean, anywhere, the spectrum is the miraculous spectrum. You know, one end you got everything imaginable. You could say that anything could happen. Great conceptualization of the gods of infinitum. And, you got all these other pieces to the spectrum, and then there's just, like, simplistic nature, a little universe in the middle of nothing, not harming anyone or anybody else. So, like, there's all different kinds of things, or maybe your other theories, too, like, magic and machine, and, basically fundamental principles. So that's pretty much it. Keep your mind open to the idea that someday there will be change and more solutions, and that right now where we're at, the topology has to lead us to a far better understanding. Otherwise, we kind of run into a stalemate. Right now, our topological study is really in particle physics. These are the things that are going to lead us to learn how to make better measurements, so that we can also speed up the process of science and also measure the body and cells and energy and everything. And right now, these are the large hadron colliders that collide protons into each other so that they can learn about particles that are inside protons. But when we do these types of things, accelerate particles and try to break them apart, we want to learn about what they do, but they may affect the universe. They may affect the planet. They may actually cause energy to do something strange in a raceway of particles. It's quite odd what really is happening when you put something that in a system that totally changes, or that doesn't agree with the system. It's like saying if somebody shoved a hot coal down your pants, you wouldn't scream bloody murder for the next 10 years. I'm pretty sure you'd be pissed. But hot coal down your pants would really piss you off. So you might not want to try that at home. Somebody will get real mad. But I think for the most part, it's all about particle physics right now. That's like the core of quantum physics, and basically the core of calculus. So try that out. We're going to call this episode Dimensions.